Summary: Causal's first insight into the mechanism of formation of electropositive and electronegative ions related the process to the attainment of noble gas configurations by the respective ions. Electrostatic attraction between ions is the cause for their stability. This gives the concept of electrovalency. The first description of covalent bonding was provided by Lewis in terms of the sharing of electron pairs between atoms, and he related the process to the attainment of noble gas configurations by reacting atoms as a result of sharing of electrons. The Lewis dot symbols shows the number of valence electrons of the atom of a given element, and Lewis dot structures shows pictorial representations of bonding in molecules. An ionic compound is pictured as a three-dimensional aggregation of positive and negative ions in an ordered arrangement, called the crystal lattice. In a crystalline solid, there is a charge balance between the positive and negative ions. The crystal lattice is stabilized by the enthalpy of lattice formation. While a single covalent bond is formed by sharing of an electron pair between two atoms, multiple bonds result from the sharing of two or three electron pairs. Some bonded atoms have additional pairs of electrons not involved in bonding. These are called lone pairs of electrons. A Lewis dot structure shows the arrangement of bonded pairs and lone pairs around each atom in a molecule. Important parameters associated with chemical bonds like bond length, bond angle, bond enthalpy, bond order, and bond polarity have significant effect on the properties of compound. A number of molecules and polyatomic ions cannot be described accurately by a single Lewis structure, and a number of descriptions, that is representations based on the same skeletal structures, are written, and these taken together represent the molecule or ion. This is a very important and extremely useful concept called resonance. The contributing structures or canonical forms taken together constitute the resonance hybrid, which represents the molecule or ion. The VSEPR theory used for predicting the geometrical shapes of molecules is based on the assumption that electron pairs repel each other and therefore tend to remain as far as apart as possible. According to this model, molecular geometry is determined by repulsions between lone pairs and lone pairs, lone pairs and bonding pairs, and bonding pairs and bonding pairs. The order of these repulsions being lone pair greater than lone pair greater than bond pair. The valence bond approach to covalent bonding is basically concerned with the energetics of covalent bond formation, about which the Lewis and VSEPR models are silent. Basically, the valence bond theory discusses bond formation in terms of overlap of orbitals.